Can you hear me okay? Yeah. So I'm Thibault, and today I'm going to talk about embedded wallet security. So what is an embedded wallet? The goal of embedded wallet product is to improve the Web3 onboarding experience, to remove the friction of having to write down a list of words and secure it in order to secure your funds. And instead to get closer to what we have in Web 2, which is you can create a wallet by a click of a button, and you can recover your account, recover your wallet if you lose your credential. But we still want to have the Web3 guarantees, which is ownership, creating non-custodial wallet, and decentralized trust. So in terms of UI, we start to see more and more on decentralized application. So it's whenever you click the usual Connect Wallet button, you have your MetaMask, Open Wallet, Wallet Connect experience. And then we start to see enter your email to create an embedded wallet, or just scan your face, scan your fingerprint, and you're going to be able to create a wallet. So that's the experience that you're exposed to when you go through the embedded wallet flow. So how is it implemented? Most of the time for the decentralized trust, you have some cryptographic protocol like Shamir secret sharing or multi-party computation, where the private key doesn't live in one place, but instead you have multiple key shares that are used to perform a valid signature. And we also see more and more passkeys that are used in order to create embedded wallets. So for ownership, whenever you have Shamir secret sharing or multi-party computation, I mean, not always, but usually you have one key share that is pushed on the client side and that lives on the browser local storage. Another type of implementation that we see is you have the on-chain private key that is decoupled from the credential that you use in order to interact with your wallet, and that creates a dual security layer. We also see a mix of the two, where you have some client credentials that does not represent the on-chain private key, but that are used to unlock some specific on-chain operation that usually requires some specific core blockchain protocol. Some support at the blockchain level. The Stellar folks are doing some great things about that, so you should talk with them if you want to learn more about it. So how does that look? Usually when you have the embedded wallet experience, you have three parties. You have the client that interact with the dApp, and then whenever you click the Connect Wallet button, you're going to interact with the embedded wallet provider, which is another party. So as a user, you're going to authenticate to the dApp. It's usually a standard Web 2 authentication. And whenever you click the Connect Wallet button, you're going to, the user experience of the embedded wallet is going to be loaded through an iframe or through a new window. And you're going to be able to enter your email, authenticate with the embedded wallet provider, and then create a wallet, and you're going to have a local share that is generated on your local browser, and then you can leverage that to perform a signature. In addition to that, usually we see an implementation of another flow at the same time, which is a recovery flow implementation. And so it's used to recover access to your wallet in case you lose your credential, or in case you change device. So if you go from desktop to mobile, since you have a share that is generated locally, when you go to another device, you don't have this share anymore, so you need a way to recover access to your wallet. So how is it done? What we've seen in production is that during the wallet creation, you have the embedded wallet provider that's going to share the authentication token with our decentralized application. This will usually be set as a cookie. And so whenever you change a device, you're going to authenticate with a decentralized application, and then the decentralized application is going to return the embedded wallet authentication token. That's fine. You're going to use this token to authenticate with a wallet provider, and then you'll be able to like generate a new, perform a key share refresh and generate a new new shares, and so get access back to your wallet. Okay, that looks fine, but if it's not done properly, this can create some issue. So as I said, you have two steps. You have like the embedded wallet provider that's going to share the authentication token with a decentralized application. And by the way, can you see all the text? Oh yeah, okay, that's fine. And then you as a client, you're going to use this authentication token to authenticate with the embedded wallet provider, and then perform a key refresh and get back into your wallet. So if it's done just like this, the first problem is that the embedded wallet provider is going to share an authentication token with a decentralized application. And this authentication token usually, I mean, in some implementation lives as a cookie under the dApp domain. And so then this cookie can be, and we've seen that in production, sometimes it's the only thing that is needed in order to perform the key refresh operation, so to authenticate with the wallet provider and perform a key refresh operation. So in other words, that means that the security of your on-chain private key is as strong as the security of your authentication token. So that's the first problem. The second problem is that this authentication token is shared with a decentralized application. So in other words, the decentralized application has access to all the secrets that is needed in order to recover your on-chain private key. So they become, sometimes without even knowing it, like a custodian of your wallet, because they can just access your private key. Also, cookies are notoriously very difficult to secure. They can live on like different data stores under your infrastructure, Sentry, Datadog, and all of that. And so remember, this now lives under the decentralized application infrastructure, and so it's difficult to secure, it's difficult to understand who has access to it. So like putting all of that together, I was able to like write a simple script that takes as an input this authentication token that now you get whenever you authenticate to the decentralized application. And you can just like pass that to this script. This script is going to make few API calls to the wallet provider, and then it's going to recover your private key. OK. So now you may wonder, this experience looks cool, but how do I know if I'm interacting with a secure system or not? So you actually have a very simple way of checking that. Is whenever you're exposed on a decentralized application to the embedded wallet experience, you can just open your console under like the application tab. So you will usually see like multiple storage that are dedicated to the dApp. That's fine. You don't have to touch those. And then you will see some local storage that belongs to the embedded wallet provider, so under the embedded wallet provider domain, cookie and storage. So what you want to do is you want to clear those storage. So like you simulate that you change device or that you don't have the authentication token anymore. Then you just refresh the page. And if you see that the wallet is loaded again without you as a user having to input any secret, that means that the dApp has all the information that is needed to like recover access to your wallet without any information from you. And so that's a problem. You're not like interacting with a secure implementation. So now if you ever want to like develop an embedded wallet experience, my advice for a secure implementation is so like two things. The first thing is to leverage as much as possible public key cryptography. So you want the client to have like a private key. It's not necessarily linked to the like on-chain private key, but as a private key, and you as an embedded wallet provider, you only have the public key, and you only use this public key to validate authentication. We've seen some embedded wallet provider like using TOTP to secure access to their system. That's not advised because TOTP is based on a shared secret. And so that means the embedded wallet provider has all the information that they need to like fake access to your wallet. And you won't be able to prove that it's not you that access your wallet because this is based on a shared secret. So always use public key cryptography so that only the client can perform some signature to authenticate to your system. Like WebAuthn and Passkey, again, are great implementation of that. And also another advice is to not expose the on-chain private key inside the client, like browser local storage, because then when you lose your device or when you go from one device to another, you need to perform a key refresh operation. That's a very sensitive operation. So advice would be to use a credential to decouple the security of the credential from the security of the on-chain private key. OK, that's it. Thank you very much. What we can say is that when we look into that, we encounter various flawed operations in production. We reported the issue to like the wallet provider each time. And so we've seen some mitigation that have been deployed following our report, so that's great, but we still have some insecure implementation in production. And so one last thing is I'm talking with a lot of people that perform like smart contract security audit, security firms that are like dedicated to smart contract. There is a lot of things to do on the infrastructure side as well, and all these like off-chain systems that interact with the blockchain. And yeah, there is a lot of like improvements that can be done and things to do. So don't hesitate to go look around that because that's an interesting area as well. Thank you very much.